let me get back here. So let us start with today's lecture, right? So we will start with unit number 3, part B, right? So you are in unit 3, part B, that deals with, am I audible clearly?
Yes,
Yes,
sir.
sir.
And screen is visible, right?
Yes, sir.
Okay, okay. So that deals with your digital ICs, right? Digital ICs. Okay, so we have seen part number A, that is your analog ICs, and now in part B we will be looking over the digital ICs. Okay, but digital ICs, there are basically before going to study the digital IC, right? We will see what is the digital signal first. Okay, so basically we will just divide our signals into three types. Okay, so what is the first type of signal what we have seen till now? So that is your analog or continuous signal, right? Isn't it? Yes. So
Yes,
what is
sir.
this signal? This signal is nothing but if you are taking the x-axis as a time axis and y-axis as, let us say, some voltage axis, right? So whatever signal you are getting, that is continuously with respect to time, right? So at each and every time instant, you can find what is the voltage of the signal. Okay. So this type of signals are called as your continuous signal. Okay. Now second is your second type of signal is your digital signal, right? Digital signal, right? Or we can also call it a discrete signal. Discrete signal, right? So what is digital signal? Or first of all, let us say that we will call it as a discrete signal. Okay, so I will try to draw the diagram of a discrete signal. Let us suppose this is the time, and again this is the voltage axis. Now what is a discrete signal? Instead of getting a continuous signal, you will get some values at some point. Can you see? So like this you will get some signal. Okay, means what? At this time instant I'm having this value, at this time instant having this value, at this time instant let us say this is the value, right? And then you can reconstruct the signal by joining the dots. Yes, no?
Yes, sir.
Yes,
Yes,
sir.
sir.
This type of signal where various levels of voltages are there, right? So this type of signal is called as your discrete signal. Kya bolenge ye signal ko? Discrete signal, right? And what is the digital signal? So digital signal is what? So is discrete signal a continuous signal? No, discrete signal is not a continuous signal. We are getting some means we can get the value at only specific time intervals. Okay, and what is digital signal? Digital signal is what? That let us say that I'm having some voltage level, right? So let us suppose this is a time axis. So we are interested in this digital signal. So let us suppose that in digital signal we will have only two levels, right? So let us say level is 0 volts and 5 volts, right? So either the signal will be, either it will be 0 or it will be 5, or it will be 0 or it will be 5, right? So there is no intermediate level. So this kind of signals are called as your digital signals, where we are considering two levels, right? We can consider multiple levels depending on how many bits we are representing for how many bits we are representing for some specific voltage. Okay, so we will see it later on. But yes, digital signal again, it will have some specific levels only, okay, in the complete set. Okay, and then there are what we can say, that there are two logic levels, right? Whenever we are dealing with digital signals, right? Or let us say that binary signals. Okay, I will say digital logic system, right? So in digital logic system, how many levels are there? Yes. So in digital logic system, how many levels are there?
Two levels.
Two levels are there, right? So one is your, you know,
Zero.
we can say, yes, we will see logic levels, right? Logic levels, or we can say logic systems. So in logic system there is, let us say, positive logic system. Now what is this logic system? That I have some axis like this. Okay, and let us say that this is we will just classify some voltages, right? Okay, let us say that this is 0 volts, this is 0 volts, let us say this is 5 volts. Okay, so whenever the signal is above 5 volt, whenever the signal is above 5 volt, okay, or 5 volts, uh, we can call it as high level, right? क्या बोल सकते हैं हम इसको? हाई लेवल बोल सकते हैं, राइट? और whenever the signal is at zero, right, we can call it as low level. Okay, so high level we can denote it by 1, and low level we can denote it by 0, right? So there are only two possibilities, right? Either the signal will be 0 volts or 5 volts. So we can consider that if any voltage that is above 2.5 volts, we will consider it as high voltage, and if any voltage which is below 2.5 volts, it is considered as a low voltage. Okay, so yes, so this line is not there, this middle line is not there, but yes, only two systems are there, or we are considering only two voltages, right? High voltage and low voltage. Okay, so in positive logic system, high is considered as 1, or we can say high as true, right? And in positive logic system, low is considered as 0, or we can call it as false, right? So this is your positive logic system, right, where higher voltages will be treated as logic 1, right? इसको हम बोलते हैं logic 1. क्या बोलेंगे? Logic 1. And whenever low voltages are there, I will call it as logic 0. Is it correct? Yes, no?
Yes, sir.
Yes, sir.
Yes.
Okay, okay. And then you can correlate, and can you tell me what is negative logic? What is negative logic system?
In negative y-axis, sir.
Yeah. So
-5.
yes. So in negative logic system, this 5 volts will be there. That will be considered as logic 0. And whenever 0 volt is there, this will be considered as logic 1. Okay, means this will be considered as false, this will be considered as true. Okay, there will be no negative axis, just we will treat high voltages as logic 0 and low voltages as logic 1. So this is the, what we can say, this is the logic system. Okay, digital logic system. Any problems in this?
No, sir.
No,
Okay,
sir.
okay, so let me go to this thing, okay, our PPT, and we will. So fundamentals of digital electronics. So for this RPJN is a very good book, reference book, and these are all the contents which we will be seeing. Okay, so basically, what are digital and analog quantities? So digital technologies, nowadays it is having very wide range of applications. For example, our cell phone, or maybe our television, communication systems, radar, navigation systems, right? So that all are nothing but it depends on the digital technology, right? So we can divide your electronics circuits into, we can divide the electronic circuit into two types. One are your analog circuits, and second are your digital circuits, right? Okay, so this analog circuits, as I have told, that they are having continuous, they are continuous with respect to time. Okay, and digital system, right, is having discrete set of values, right? Now if we consider only two levels, then it will have two sets of value. One will be low voltage value, another will be high voltage value, right? So analog का example क्या दे सकते हो? What is the air temperature which is changing with respect to time? Because you can measure at each and every instant, right, what is the temperature of the air. Okay, but if we are considering, or if we are measuring the air temperature after particular interval of time, let us say that we are considering the air temperature after every 1 hour. Okay, so means what, you can get different readings, right? For example, the temperature at 12 o'clock is this thing, right? But we are not measuring, we are not interested to measure the temperature at 12:15. Okay, so for how many intervals are there? So let us say that 12 intervals will be there, so we will take only 12 values, right? Means what, this is which signal? This is a discrete signal, and then we can also make some another signal out of it. Okay, we can convert this discrete signal into digital signal by using some binary system, binary number system. Okay, but we will concentrate only on the two number system, that is your logic 1 and logic 0, or to only two levels, right? Now why we are using the digital systems, right? Just 1 second. So why we are using this digital systems, because okay, so because digital systems are having various advantages, right? So one of the advantage of the digital system is they are more effective as well as reliable, right? Let us consider, आप बता सकते हो मुझे हम watch कौन सा use करते हैं, analog or digital? So there are both type of watches are there, right? So which means what are the advantages of digital watch? और लेट अस सपोज हम मल्टीमीटर यूज करते हैं, राइट? वोल्ट मीटर यूज करते हैं, एक एनालॉग रहता है और एक डिजिटल रहता है, राइट? सो व्हाट आर द एडवांटेजेस ऑफ डिजिटल सिस्टम?
Easy to read.
या इजी टू रीड, राइट? More accurate and
Yes,
precise.
accurate and
Yes, sir.
precise.
Correct. So this is point
Less
number
errors.
3. Yes, this is point number 3. Then is it free of noise?
Yes, sir.
A
Yes,
little bit,
sir.
sir. Yes, sir.
Yes, it is
Yes.
free of noise. Then digital signal has great advantage when storage is necessary, right? बराबर है? पहले
Yes, sir.
एनालॉग सिग्नल अगर स्टोर करना रहता है, राइट? इफ यू वांट टू स्टोर द एनालॉग सिग्नल, राइट, लेट अस से MP3 सॉन्ग, तो फिर हमें पहले कैसेट आते थे, राइट? कैसेट
Yes,
पता है
sir.
आपको?
Yes, sir.
सो देखिए ना, एक कैसेट में लेट अस से 10 सॉन्ग्स वाज गेटिंग फिटेड, एंड नाउ कैसेट साइज वाज लेट अस सपोज मींस 5 सेंटीमीटर बाय 10 सेंटीमीटर, एंड नाउ 5 सेंटीमीटर क्रॉस सेंटीमीटर 10 सेंटीमीटर का अभी आपके पास हार्ड डिस्क आता है, 1 TB का हार्ड डिस्क, राइट? सो जिसमें आप हजारों गाने स्टोर कर सकते हैं। यस,
Yes, sir.
Yes, sir.
so can I
Lot
say
of any, sir.
digital? So this has made a very big revolution in the electronics industry, where the data first it was getting stored in analog form. So analog में क्या होता है, circuit बड़े रहते हैं, components बड़े रहते हैं, equipments बड़े रहते हैं, right? So when it comes to digital, right, obviously what we have seen, a very large scale, right, technology, VLSI, okay, very large scale integration. So the sizes are becoming compact, okay, and functions are increasing, okay. So these are the advantages of digital system. Now analog system, let us say that we will take a simple example of a linear amplifier circuit which we have seen yesterday. So microphone, it will convert the sound energy into audio signal which is continuous in time, and amplifier will increase it, right? So we have seen BJT as amplifier. So some higher versions of amplifiers are there. It will amplify the signal and speaker will again reproduce the sound wave, right? So this is a specific means what we can say audio system where we are getting output at each and every instant, right? So this is a typical example of analog system. Now what is analog system where the digital signal is or digital things are getting involved, right? So now we are not having a CD, we are not having a tape recorder, we are having a CD, and on CD the data is stored only in the form of digital system, that too in the form of only two levels. कौन से level है? एक तो zero में data रहेगा, नहीं तो one में रहेगा, right? So whatever data is there that we are storing in the form of zeros or one, right? So what we are what we are doing, first we are reading the data from the CD, and then that data is your digital data which we are converting it into analog form by using digital to analog converter. Once it is getting converted into analog form, then your linear amplification and speaker will do its job, right? So getting what we are doing, we are just storing the data in the digital form. Is it okay?
Yes, sir.
Yes.
Yes, sir.
Okay, so this is the thing, okay. Now uh, now mechatronics, right? So we are having various applications, right? When these things got evolved, right, we can have the applications in various industries, right, like mechatronics, right, where in mechatronics what we are doing, we are using a processor, right? So in processor what is there, all digital circuits are there, and we are using processors, or we can say microcontrollers, to control various applications. So if you have been into any car manufacturing industry, right? So in car manufacturing industry, maybe there are welding shops, right? So welding is not done manually. Arc welding is there, that is being done automatically, right? So let us say that the car frame will come, roof will come, and then automatically the roof will be aligned with the frame, and automatically there is a robot who will do proper welding, uniform welding on all the sides of the roof, okay. So only Volkswagen will do the welding kind of thing in the roof. बाकी के जो manufacturers OEM बोलते हैं हम उसको, original equipment manufacturers, right? They are having some different technologies, but anyway, for some specific applications, right, we are having robotic arm which will do a specific thing in a, you can say, line of production. Okay, so here are the applications of digital electronics, right? Now we can say that this digital electronics, right, it uses only two digits, that is digit 0 and digit 1, right? So only two digits, that's why it is called as your binary number system. What we can say it as binary means what? Only two, right? So each of the two digits, right, in the binary system, 1 and 0, right, is called as one bit. बराबर है? मतलब एक डिजिट को क्या बोलेंगे हम? बिट बोलेंगे, राइट? सो हाउ मेनी बिट्स आर देयर इन बाइनरी नंबर सिस्टम?
2 bits.
2 bits, right? Okay, now we can collectively have the combination of the bits, right? So two different voltages level, which will represented by only 2 bits, right? So let us say one will represent as high voltage and zero will represent as low voltage, right? So जब one को high voltage बोलेंगे, zero को low voltage बोलेंगे, so this system is called as your, yes,
Positive.
पॉजिटिव लॉजिक सिस्टम, राइट? तो यही बताया था ना, दिस इज योर पॉजिटिव लॉजिक सिस्टम एंड विच वी विल बी यूजिंग इन our topic thoroughly. Okay, so whenever this topic is concerned, right, so at this time we will be considering the positive logic system throughout our topic. Okay, so this is the thing, right? There is some voltage, right? Let us say we can call it as a range. जैसे मैंने बोला था 5 volts, right? So ये मैं बोल सकता हूँ 5 volts 4 और 5 के बीच में what we will assign a digit as 1, and let us say 0 और 1 वोल्ट के बीच में हम बोलेंगे that it is low voltage, right? और इसके बीच में अगर कुछ वोल्टेज आता है, so that voltage we will call it as unacceptable voltage, or that is not accepted voltage. Okay, yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, great. So this is your positive logic system. लॉजिक 1 फॉर हाई, लॉजिक 0 फॉर लो, राइट? सो मैंने 4 लिया था, इन्होंने 3.5 ले लिया, थोड़ा ज्यादा टॉलरेंस रखा, नॉट अ प्रॉब्लम. ओके, सो यस, एग्जांपल्स ऑफ डिजिटल वेवफॉर्म. अभी जो डिजिटल सिस्टम है, सो उसमें डिजिटल वेवफॉर्म्स भी आएंगे, राइट? सो डिजिटल वेवफॉर्म्स मींस व्हाट? इट विल हैव only two levels, right? Which are the two levels? This is 0 and this is 1. 0 means, well, let us say it is 0 volts, and 1 means what? Let us consider it as 5 volts, right? So whenever this see, at this time your voltage is high or low? High. So let us say that your circuit is on and यहाँ पर आपका voltage कैसा है? Low है. So let us say that this is circuit is off, right? So on time plus off time is equal to 1 period. समझ में आ रहा है आपको? On time plus off time is equal to 1 period. Yes, no?
Yes, sir.
So
Yes,
Yes,
this
sir.
sir.
is the time period of one cycle, right? This is called as time period of one cycle. And if the wave is uniform, that is the period of each and every cycle is equal, t1 equal to 2, t2 equal to t3, right? And if on time is equal to off time, then we will call this wave as a square wave. क्या बोलेंगे इसको? We will
Square
call it
wave.
as a square wave, right? And we can easily calculate the period as well as frequencies inverse of the time period. Okay, now the second is your non periodic, right? Like for example, this is your, ये बोलिए, ये कौन सा टाइम है? ऑन टाइम, ऑफ टाइम?
On time.
एंड
On
ये
time.
कौन सा टाइम है?
Off.
Off time.
ऑफ टाइम,
Off
राइट? सो
time.
दिस इज ऑफ टाइम, राइट, एंड दिस इज ऑन टाइम. नाउ ऑफ टाइम और ऑन टाइम का पीरियड जो है वो डिफरेंट है.
Yes,
यस.
sir.
Yes, sir.
सो
Yes,
कैन आई
sir.
कॉल इट एज रेक्टेंगुलर वेवफॉर्म? Maybe
Yes,
Yes,
sir.
yes.
sir.
Okay. Second thing, we cannot calculate its frequency, but for this non-periodic signal, we can calculate the duty cycle, right? So what is duty cycle? What is duty cycle? So duty cycle is nothing but ratio of pulse width, right, to the period cycle, right? Pulse width to the period cycle. Now pulse width मतलब क्या? Pulse width is nothing but your on time width, right? On time width को हम बोलते हैं pulse width, right? So we can call it as t on upon total time. Total time मतलब क्या होगा आपका? t on plus t off. समझ में आ रहा है?
Yes,
Yes,
sir.
sir.
Yes. So let us suppose ये 5 millisecond है and this is 15 millisecond. So what is duty cycle? What is duty cycle? It is ratio of 5 milli divided by
20.
5 plus 15. मिली. So what is it? 1/4 का ड्यूटी साइकिल है, राइट. 1/4 मीन्स व्हाट? 25% का ड्यूटी साइकिल है. समझ में आया?
Yes, sir.
Yes,
Yes,
sir.
sir.
Getting? So this is the duty cycle of the waveform. Okay, any problem in this? I guess no
No,
problem,
sir.
right? It's simpler things which we are covering. So this kind of waveforms are called as your digital waveforms. So a square wave, typically we call it as a clock signal, right? Square wave we call it as a typically clock signal. Now what are the uses of clock signal? मैं आपको बाद में बताऊंगा. Okay, and then clock signal is having some frequency, or we can say time period. So the time period, one cycle is called as bit time. क्या बोलेंगे हम इसको? Bit time. Okay, so let us suppose that if I want to give a sequence 10100, ये अगर sequence मुझे पास करना है, नहीं तो फिर मैं क्या करूंगा, मुझे sequence अगर आपके हार्ड ड्राइव में, नहीं तो फिर सीडी में स्टोर करना है, तो मुझे सिग्नल कैसे देना पड़ेगा? सिग्नल कैसे देना पड़ेगा? लेट अस सपोज इट इज वर्किंग ऑन सम वोल्टेज लेवल्स ऑफ 0 वोल्ट्स टू 5 वोल्ट्स. तो मुझे क्या करना पड़ेगा? ये क्लॉक सिग्नल मुझे रेफरेंस रखना पड़ेगा, और 1 देना है तो मुझे क्या करना पड़ेगा? एक बिट टाइम के लिए मुझे क्या करना पड़ेगा? 1 देना पड़ेगा. मतलब इतने टाइम के लिए मुझे कितना वोल्टेज देना पड़ेगा? 5
5
वोल्ट्स. उसके बाद में 0 देना है तो फिर 1 बिट ऑफ टाइम के लिए मुझे कितना वोल्टेज देना पड़ेगा? 0 वोल्ट देना पड़ेगा. फिर से 1 देना है तो फिर से एक बिट टाइम के लिए 5 वोल्ट देना पड़ेगा, राइट. फिर से अभी एक बार 0 है तो एक बिट टाइम के लिए 0, फिर से दोबारा 0 है तो इसको 0 ही रखो. समझ में आ रहा है आपको?
Yes, sir.
Yes, sir.
तो फिर ऐसे करके मैं क्या कर सकता हूँ? आई कैन गिव द वोल्टेज टू द सीडी. और आपके पास सीडी राइटर होगा, नहीं तो पेन ड्राइव में जब डेटा राइट होता है तो वोल्टेज से राइट होता है. गेटिंग? सम ऑप्टो इलेक्ट्रॉनिक devices are there which will write the data on the CD, right? But to operate the opto electrical device, we need to give the voltages in this kind of form. Getting? So these signals are nothing but these are called as your digital waveforms. Getting?
Yes, sir.
So
Yes,
Yes,
sir.
sir.
हमें सिग्नल्स देने के लिए रेफरेंस कुछ तो भी चाहिए ना. सो व्हाट इज दैट रेफरेंस? दैट रेफरेंस इज कॉल्ड एज योर क्लॉक सिग्नल. बराबर है? व्हाट इज कॉल्ड एज योर क्लॉक सिग्नल? द
Reference signal.
रेफरेंस. हाँ, द
Reference signal.
रेफरेंस सिग्नल. सो जैसे हमारा व्हाट वी आर सीइंग, जब हम प्रोसेसर लेते हैं, नहीं तो फिर लैपटॉप लेते हैं, नहीं तो फिर हम हमेशा जब आपका मोबाइल फोन लेते हो, तो व्हाट यू सी मेनली?
Processor and RAM.
हाँ, रैम देखते हो, दैट इज वन थिंग. सेकंड, स्टोरेज, हार्ड डिस्क देखते हो. कैमरा एंड ऑल दैट आर नथिंग बट एसेसरीज, वी कैन से. ओके, एंड व्हाट इज इंपॉर्टेंट, यू सी द प्रोसेसर. प्रोसेसर कैसे देखते हो? इंटेल का ले लिया प्रोसेसर, ऐसे करते हो? नहीं. सो इन दैट प्रोसेसर ऑल्सो यू कैन सी व्हाट इज द, व्हाट यू आर सीइंग, सम गीगाहर्ट्ज
Clock,
और समथिंग.
clock speed.
Processor speed.
हाँ.
Clock speed.
हाँ, तो हाँ, सो
Refresh
दैट इज योर
rate.
क्लॉक स्पीड. जितना क्लॉक स्पीड ज्यादा रहेगा ना, उतना आपका प्रोसेसर का स्पीड ज्यादा रहेगा. इजंट इट? यस, नो?
Yes, sir. Yes, sir.
ओके,
Yes, sir.
सो
Yes,
लेट
sir.
अस सपोज ये क्लॉक स्पीड जो है ना, ये आपका 1 सेकंड का है, राइट. सो अगर 0.5 सेकंड्स का लिया तो क्या कैसे आएगा? ऐसे आएगा, राइट. मतलब इससे डबल स्पीड हो गया ना.
Yes, sir.
Yes,
सो
yes, sir.
so we are looking towards the clock speed. So समझ में आ रहा है? Clock will always give a reference signal. Yes, no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So these are nothing but the digital waveform. Now data transfer, same. I am saying that okay, there is some sender device, there is some receiver device. तो आपको समझ में कैसे आएगा कि डेटा कैसे सेंड हो रहा है? तो मैं क्या करूंगा, सेंडिंग डिवाइस और रिसीविंग डिवाइस दोनों का क्लॉक फ्रीक्वेंसी अगर सेम रखता हूँ, ओके, तो जब हाई वोल्टेज आएगा तब मैं क्या कंसिडर करूंगा? मेरे पास 1 आ गया. जब लो वोल्टेज आएगा तब मैं क्या करूंगा? आई विल कंसिडर दैट इट इज 0. यस, नो?
Yes, sir.
Yes, sir.
सो
Yes, sir.
समझ में आ रहा है किस प्रकार से डेटा ट्रांसफर हो रहा है?
Yes,
I am
sir.
not sending ones and zeros. I am just changing the voltage levels, and with the voltage levels, I am what? I am identifying at the receiver end what is the bits which I am receiving, right? That let us suppose that मैंने मतलब एक कोडिंग कर लिया एक प्रकार से, राइट. सेंडर बोलता है कि ओके आई विल यूज दिस क्लॉक फ्रीक्वेंसी, रिसीवर बोलेगा ओके नो प्रॉब्लम आई विल आल्सो यूज सेम क्लॉक फ्रीक्वेंसी. एंड देन सेंडर विल से ओके 5 वोल्टेजेस मींस लॉजिक 1 मींस पॉजिटिव लॉजिक सिस्टम यूज करेंगे. सो रिसीवर में अगर 5 वोल्ट्स आया तो वो डिकोड करके बोल देगा 1 आ गया. अगर 0 वोल्ट आ गया तो बोलेगा 0 आ गया. अगर फिर से 5 वोल्ट आ गया तो फिर से बोलेगा 1 आ गया. फिर से 5 वोल्ट आ गया फिर से बोलेगा 1. सो लाइक दिस वी आर सेंडिंग 1 0 1 1 0 0 1 0 from sender to receiver end. Is it correct? Yes.
Yes, sir.
Yes, sir.
Okay.
Yes,
And
sir.
now we are having a decimal number system with us. So 23 को हम कैसे मैनिपुलेट करते हैं और कैसे इंटरप्रेट करते हैं. So this is your units place digit, this is your tens place digit. So जैसे हम लेफ्ट टू राइट जाते हैं, राइट सॉरी जैसे हम राइट टू लेफ्ट जाते हैं वैसे सिग्निफिकेंस कैसे बढ़ते रहता है, राइट. सो इसका मतलब सबसे पहला डिजिट है डेसिमल. डेसिमल मींस व्हाट पावर यू विल टेक. डेसिमल मींस व्हाट पावर यू विल टेक द पावर ऑफ
10.
10, right.
10.
So ये है आपका 10 raised to 0, right. So because this is 0th place, this is first place, so this is 10 raised to 1, and then multiply with the significant bits, and then this will be 2 into 10 20 plus 3 into 10 raised to 0, that is 1, and then you will get 20 plus 3, that is your 23. Okay, so this is like how you interpret the decimal numbers, right. Yes, no. सो ये जो 10 रेस टू 0 10 रेस टू 1 यहाँ पर अगर 123 है तो इसको कैसे लिख देंगे हम 1 into 10 रेस टू 3, करेक्ट. yes, no. So it will
Yes,
be
sir.
10 raised to 2, sorry 10 raised to 2, so it will be 100. So it will be 100 plus 23,
23.
it will be 123, correct. So this 10 raised to 0 10 raised to 1 10 raised to 2 in decimal number systems, these are called as weights. So weights क्या रहेंगे, ये वाले weights रहेंगे from left to sorry from right to left, correct. Yes, no.
Yes, sir.
So
Yes.
Yes, sir.
अभी तक हाँ अभी तक हम ऐसा सीखते आए, राइट. From the childhood we are seeing decimal number systems, right. So binary number systems are also we are copying from decimal number system. So decimal में कितने digit होते थे 0 1 2 3 4 up to 9. So how many digits are there, 10. So that's why the weight is 10. So in binary how many digits are there, only 2. So what is the weight, weight will be
2.
2, correct. Okay, so now you know weight अगर 2 है तो let us take an simple example, right. Let us take the simple example. Let us say that this number binary number is 1010. Okay, so how weights will be, इसका weight क्या रहेगा 2 raised to 0, इसका weight क्या रहेगा, सेकंड वाले का weight क्या रहेगा 2 raised to 1, थर्ड वाले
2 raised to 2, 2 raised to 3.
2 raised to 2 2 raised to 3. So or significant bits, so this is 2 raised to 0 2 raised to 1 2 raised to 2 2 raised to 3, और जो कोई डिजिट है उससे मल्टीप्लाई कर दीजिए. सो हाउ मच इट इज 0 plus 2 raised to 1 into 1 2 2 raised to 2 into 0 0 2 raised to 3 is
8.
8, and then just add it. We are converting and then just add it, right. So what is this, this is your binary number, and what is this is your decimal number, getting. So are you converting binary number into decimal number? Yes.
Yes, sir.
So
Yes,
this
sir.
is binary to decimal conversion, getting. This is
Yes, sir.
binary to decimal conversion. Yes, no. Okay, okay. So like this, so this is your binary to decimal conversion, and you can convert or you can write the equivalent decimal equivalent of the binary number, right. Okay, now let us see that how we can write it out. Okay, so these are your binary weightages, right. 2 raised to, from right to left, from right to left, 2 raised to 0 2 raised to 1 2 raised to 2, like that. Yes, no.
Yes, sir.
Okay,
Yes, sir.
now you just see that अगर डेसिमल पॉइंट है, डेसिमल पॉइंट है, तो डेसिमल पॉइंट के बाद में फिर नंबर्स कैसे आएंगे. देखिए आपका नंबर है, सुनिए बाइनरी डिजिट्स में आपका नंबर है x x x x x पॉइंट x x x x x, राइट. सो इसके डेसिमल पॉइंट के लेफ्ट में जो है उसमें कौन से पावर लगेंगे, यहाँ पर कौन सा पावर लगेगा 2 raised to 0, यहाँ पर कौन सा लगेगा 2 raised to 1, यहाँ पर कौन सा लगेगा 2 raised to 2, यहाँ पर कौन सा लगेगा 2 raised to 3 समझ में आ रहा है?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
डेसिमल पॉइंट के राइट साइड में कौन सा लगेगा? पहला 2 रेस टू -1, दूसरा 2 रेस टू -2, तीसरा 2 रेस टू -3, चौथा 2 रेस टू -4. समझ में आ रहा है आपको? यस?
Yes, sir.
Yes, sir.
Yes.
हाँ हाँ. So like that we will be using the same, we are copying from decimal number system only. Okay, so this is binary to decimal number conversion. Yes, is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay. And now, you know, if you want to convert binary to decimal, this is the procedure, correct?
Yes, yes, sir.
तो पहले हमने सिर्फ 4 डिजिट वाला लिया था 1010. नाउ इट इज 8 डिजिट नंबर. सो इसका 1 into 2 raised to 0, 0 into 2 raised to 1, 0 into 2 raised to 2, then 1 into 2 raised to 3, this one multiplied by its weight, this one multiplied by its binary weight, this one multiplied by its binary weight, and then you just do the multiplication and whatever total is coming you have to add it, so you will get 217. So इसका मतलब ये है कि this in binary is equivalent to 217 in decimal. समझ में आ रहा है?
Yes, sir.
ओके मतलब आपको अगर 217 अगर एक एंड से दूसरी एंड को भेजना है, सो यू नीड टू 8110, वी नीड टू सेंड द 8 डिजिट्स, दैट इज 11011001. करेक्ट?
Yes, sir.
ओके. सो बाइनरी टू डेसिमल ये स्टेप्स में आपको अभी now see here, now second is decimal to binary. Okay, now second step we need to convert the numbers from decimal to binary. Okay, and once we complete this we will stop our lecture. Okay, so the process is simple, the steps are given, and what I will do, I will just directly take an example. I think you might be knowing. So हमें क्या करना है? Step number 1, we need to write 25. Let us say that we need to convert 25 into binary. So मैं पहले क्या करूँगा? 25 को क्या करूँगा मैं? 2 से divide करूँगा. So what is remaining? What is the quotient and what is the remainder? 2 ones are 2,
12 है और remainder
12, and remainder is 1.
1.
So what I will write? I will write the quotient here. I will write the remainder here. Sorry, I will write the remainder here, right? And I am dividing it by 2. Correct? This is remainder, this is quotient. Okay. Now again I will divide 12 by 2. What is quotient? 6, remainder 0. So I am writing here quotient, I am writing here remainder. Correct? Yes, no?
Yes, sir.
Again
Yes.
6 by 2. Quotient is 3.
3,
Remainder is 0.
0.
3 by 2. Quotient is 2 ones are 2. Remainder is 1. बराबर है? Yes, no?
Yes, sir.
And
Sir.
1 by 2,
Yes, sir.
directly I will get remainder. Quotient is 0. Yes, no?
Yes, sir.
Yes,
Yes,
sir.
Yes,
sir.
sir.
And then we have to read in the reverse manner, right? Reverse manner मतलब क्या? नीचे पहले लेकर ऊपर बाद में लिखिए. तो सबसे पहले this is your 1 1 1 0 0 1. उल्टे मैनर में आपको रीड करते जाना है. सो दिस जब आप उल्टे मैनर में रीड करेंगे तो आपको कुछ नंबर मिलेगा. देखिए रिमाइंडर 2 से डिवाइड किया तो एक तो 0 नहीं तो 1 ही मिलना है, राइट? सो व्हेनेवर वी आर रीडिंग इन द अप डायरेक्शन आई विल गेट द बाइनरी नंबर 11001. Okay, you may check it and you may again convert this binary into decimal, you will get 25 only. Is it easy?
Yes, sir.
Yes, sir.
Simple है. Okay, now 160 का देखेंगे हम लोग. बोलिए क्वेश्चन 160. You can take it as a homework. 160 आपको बाइनरी में कन्वर्ट करना है. सो 0 0 0 0, यहाँ पर सिर्फ 1 आएगा और यहाँ पर 0. सो दिस इज योर 1 0 यहाँ से आएगा. समझ में आ रहा है आपको?
Yes, sir.
ओके.
Yes, sir.
सो यहाँ पर सिर्फ 0 से चालू मत कीजिएगा. ओके, यहाँ पर 1 से चालू कीजिए. यस, नो?
Yes.
Yes, sir.
Okay, great. So it is 101 and then 0000. Okay, so just see it once at home and you will understand easily. नहीं समझ में आता है तो फिर पूछिए मुझे. Okay, so this was decimal to binary and binary to decimal conversion till now, And I guess that you don't have any problem in this. Any
No
problems?
problem, sir.
No, sir.
Was it easy?
Yes.
Till
Yes, sir.
Yes, sir.
Okay. And then simple, we will just have a binary addition, right? So this is one slide which we will be completing today, last slide. So binary bits, only two binary bits. So what are the possibilities? Either I can add 0 with 0, 0 with 1, 1 with 0, and 1 with 1. Okay. So whenever I'm adding 0 plus 0, right? Whenever I'm adding 0 plus 0, like देखिए decimal में क्या होता है? 9 plus 2. What is 9 plus 2?
11.
हाँ, 11. So ये 1 को बोलते हैं हम सम, और ये 1 को बोलते हैं हम कैरी. ओके. सो यहाँ पर क्या होता है? 0 प्लस 0, सम इज 0, कैरी इज 0, इसलिए सम 0 कैरी 0 ऐसा लिखा है. समझ में आया?
Yes, sir.
1 प्लस 0 नहीं तो 0 प्लस 1, सम इज 1, कैरी इज 0. समझ में आया?
Yes, sir.
एंड देन व्हाट इज 1 प्लस 1? 1 0. सो सम इज 0, कैरी इज 1. समझ में आया?
Yes, sir.
जैसे
Yes, sir.
9 प्लस 1 क्या होता है? 10 होता है. कैसे होता है पता है क्या आपको? यस नो, कैसे होता है
No,
एक्चुअली? यस नो. देखो क्या होता है ना, डेसिमल में क्या होता है? 0 के बाद में 1, के बाद में 2, उसके बाद में ऐसे आएगा 8, 8 के बाद में 9, 9 के बाद में क्या आएगा? फिर से 0.
0.
तो
0.
इसका मतलब ये है 0 प्लस 1, मतलब क्या? एक बार शिफ्ट कर लीजिए. सो 0 प्लस 1, 0 को एक नंबर से शिफ्ट किया तो हमें 1 मिला. ऐसा एडिशन होता है, बराबर है? तो 9 को एक नंबर से शिफ्ट किया, 9 प्लस 1, सो 9 को एक नंबर से शिफ्ट किया तो क्या हो गया? 0 मिल गया मुझे.
0.
लेकिन फिर से दोबारा साइकिल चालू हो गया ना, मतलब एक साइकिल कंप्लीट हो गया, इसलिए हम बोलते हैं कैरी 1. समझ में आ रहा है? सो लाइक
Yes,
दैट
sir.
इन बाइनरी नंबर सिस्टम, 0 के बाद 1, 1 के बाद में 0. सो 1 प्लस 1, 1 को एक बार शिफ्ट कर लो, 0 आ जाएगा. एक साइकिल कंप्लीट हो गया, इसलिए 1. सो ये आ गया आपका कैरी, ये आ गया आपका सम. समझ में आया?
Yes, sir.
So
Yes, sir.
this is called as your binary addition. Okay. So I guess it's quite simple. Yes.
Yes, sir.
Yes, sir.
Okay. If you have any difficulties, we can discuss it.